So you can see this is the 10th iteration of Basecamp that we have done since I think 2 years ago when we started the first time. So about Basecamp. So as you know, it's an initiative from the Starknet Foundation, and the idea is to help developers to onboard into the Starknet ecosystem. And this week, this particular iteration is going to be 5 weeks. Okay, so fundamentals, right? So what do we cover today? So we're going to cover 4 topics. First of all is why Cairo, all the motivation of why this programming language, why we chose to create our own programming language, why didn't actually use Solidity for Starknet, and then why Starknet, right? What makes this layer 2 so special, so unique compared to other layer 2s, like, I don't know, CK Sync, like Polygon, Scroll. We're going to talk then about smart wallets, which is a feature that is enabled because of a CAN abstraction. So you're gonna see how using a CAN abstraction allows you to create a wallet that has way more features, is actually more secure. Okay, so we have 4 names here, right? We have Starkware, we have StarkX, we have Starknet, we have the Starknet Foundation. And this is typically a confusion about what does it mean, each one of those names. You probably know Starknet, right? But what is a Starkware? So Starkware is the company who developed all the technology that powers Starknet. So Starknet developed this specific type of zero-knowledge proofs called Starks. They developed the Cairo language. They developed Starknet itself. So this is the company just fully based on engineers creating technology. Now, the first, let's say, service created by Starkware using this technology, this zero-knowledge or ZK Starks, was not a Starknet. It was actually a service called a StarkX. And a StarkX is also a layer 2. It's considered to be a Validium. And a StarkX is what powers a lot of applications. If you've been in the space, you will know like DYDX, you will know Immutable X or Rhino5. All of those systems actually use StarkX under the hood, even though they don't say it publicly. But it's basically a way to secure all these transactions in a very cheap way, because that's why it's a Validium. And it's also very secure. It also lives on top of Ethereum and uses Ethereum as a security layer. The interesting thing about StarkX is that it is a permission system, meaning that you cannot just go and deploy a smart contract to StarkX. Actually, StarkX's capabilities are fixed. It only knows how to do a few things like trading tokens, NFTs, or futures, or synthetics. But for you to use it as a company, you will need to enter in some kind of a formal agreement with the Starkware to be able to use it, right? So it's not a smart contract based and it's permission, but it's very performant and very cheap. Then you have a Starknet. Starknet was the second, let's say, big project that Starkware built using these technologies, but it went a step further. So now Starknet is actually a fully layer 2 rollup. And it's permissionless, meaning that anyone can go and use a Starknet and deploy their smart contracts and create their businesses on top of that without asking anyone for permission. You only have to pay gas fees or to deploy and users in order to use the smart contracts like any other blockchain. So yeah, so Starknet came after StarkX. Starknet has extra guarantees of liveness in particular, and the fact that it's permissionless, it opens up the space and it's flexible, right? You can build any logic that you want there. So it doesn't have the limitation that StarkX had. Finally, we have the Starknet Foundation, which is where I work in. Is a separate entity from Starkware. It's actually a non-profit organization. And the goal of the foundation is trying to help foster the Starknet ecosystem. We do that through like this training that we're doing today, hacker houses, all these educational events and like marketing as well, but also supporting developers with grants at different stages of the product cycle, just to make sure that we have a good amount of applications living on a Starknet and taking advantage of all these technologies that we have there. I see a few questions on the Q&A. Simon is asking, Starknet uses ETH for gas? That is a good question. So currently, yes, you can use ETH to pay for gas fees on a Starknet, but you can also use the Stark token to pay for gas fees. So it's like a dual token that you can use for gas. Long term, the plan is only to use the Stark token for gas fees. But for now, you can use both. And I don't know when support for ETH as a gas fee is going to end. But the thing is, we are also working on a paymaster approach for the whole chain. So you will be able to pay gas fees in any token you want. And under the hood, it's just going to do the transformation to whatever gas the network is expecting. So it's going to be transparent to the user. But yeah, but today you can use ETH and Start for paying gas fees. Right. Why Cairo? Why this programming language in the first place? Let's go take a look at it. I like to explain the benefits of Cairo and the idea of verifiable computation with an example that I taught many times. So I'm sure as people here have seen this talk before. But imagine you're the head of a space exploration agency of a small country, right? And your goal is to send a spacecraft, like a robotic spacecraft, to Mars, right? To do some measurements. So to do that, you need to do some important calculations in order to save fuel, because the more you can save in fuel, the smaller the rocket, the cheapest the whole mission is going to be. So you have to calculate what is the best launch window, like when should you launch the spacecraft? So, it's going to be the shortest path, and what's going to be the best trajectory to get there. So if you get those two variables right, you're going to be able to save a lot of money in the project. So what you do is you turn your engineering team, hey, could you create the program or the algorithm that's going to calculate all these two variables? And maybe use Rust. Use a very performant language, because it's going to be a complex calculation, so it better be efficient, whatever program you use. So sure enough, the engineers go and create the program, and they do it with Rust. It could be C++. Think about your favorite and fastest language you can use. But they have an issue, right? The execution of this program is going to be so complex, and it's going to require so much power that you can only do it in a supercomputer. In a supercomputer that you don't have, right? Because your space agency is not NASA, it's not the biggest one. So you don't have the resources. But lucky for you, a rival country has one supercomputer and has decided to actually, participate and let you in some way. So the way they support you is that they say, okay, actually, if you give us your program, we can run it for you. And then after a while, when it's ready, just give you the answer, right? Maybe charge you a fee, but that's fine. We are a rival country, but we can collaborate. So they say, okay, sure, you give them the program, they execute it, and sometime after, they give you the results, say, hey, this is the best time to launch the spacecraft, and this is the perfect trajectory to get there. But you have an issue, right? You get the result, but how do you know if that result is actually the output of your program? Right? You don't have a way to independently execute the programming and compare results. You don't have the supercomputer. So you have to pretty much trust that the rival country is giving you the right result. But a few things could have happened in the middle. It could happen that the supercomputer, some small malfunction, some bit flopped, and the answer is a bit off. Or maybe in purpose. Remember, they are a rival country. I don't know if they can be trusted. Maybe the spy agency of the country decide to small change. It's small enough so you cannot detect it easily, but enough to completely derail your mission. So you don't know, can you trust the results? Not really. So this is the issue when you have a language, like a traditional language, right? Like Rust, like C++. You have no way to know if the result is actually the output of your computation if you don't do it yourself. So let's go back and run the same scenario, but now your engineers, instead of using Rust for the program, they actually use Cairo to create the program. So now what's going to happen is that, again, you give them the program for them to execute, but because they're using Cairo and they will run it in the Cairo VM, now when they get back to you, not only they give you the result, but they give you the proof of the integrity of the computation, right? Basically proving that that result is actually the output of the program that you gave them. You can take that proof, and the proof is small enough that you can just verify in any computer. You don't need to have could be a smartphone. And if the proof is verified correctly, you have without any doubt that you will know that the result is actually the output of your program. So you will know that no one tampered with the result on purpose, like trying to sabotage you, because if they did, the result will be invalid and you'll know right away. But also you will know if the computer didn't malfunction during the execution of the program. So that is a very powerful feature. So now you can collaborate with a rival in a wasteless, right? But you don't need to have the resources that they have. So in other words, when you use Cairo, a regular computer is able to keep a supercomputer honest. And this is going to be a key feature that's going to allow the Starknet to scale and to do way more computation that is possible in a traditional blockchain architecture like Ethereum, for example. Someone is asking, so Cairo is a general purpose language, not only writing Starknet smart contracts. Yes, correct. You can use Cairo for anything, not just smart contracts. And that is a very unique feature of the language, right? Because these days you can also use Solidity in a zk EVM environment, so you can take advantage of zero knowledge proofs. using Solidity, but Solidity you can only use it for smart contracts. You cannot use it for general purpose language. You can use Cairo for anything. That is a powerful thing that now you can use these properties in a completely unexpected ways that might not be blockchain at all. Because the prover technology is actually open source. It's called the Stone Prover. Andesh is asking, is the proof something like a hash? It's much more advanced than a hash. It's based on polynomials, polynomial constraints. It uses some hashes under the hood, but it's way more advanced than the hash because what it proves to you is the integrity of the computation. And this is a breakthrough that actually Starknet had a few years ago. Like the paper came out in 2018, and the CEO of the company is actually the cryptographer from Israel who actually came up with this set of technologies. And eventually he created Starknet is just to commercialize the technology and to put it into practice somewhere. And he found the blockchain to be a perfect place to do it. So it's way more advanced than a hash because a hash is just like a fingerprint of a digital file only. Mihir is asking, can't the proof be tampered to prove that the computation was true even if it's not? So the chances that you can do that are extremely, extremely, extremely small. They're not zero, but they're so small that you can say that it's basically impossible, right? So that is an interesting property that even if you try to cheat, you won't be able to fool if the verifier is built correctly. That's why it's important that you run the verifier yourself. Then they won't be able to cheat, to give you a tamper proof. Mohammed is asking, the time taken for ZK consensus takes too much time to generate proof, so how is it better than other networks? Then the consensus, right? So the question is, generating a proof takes a long time. How is that actually better than regular consensus? And the answer is that with the Starks, you have a feature that is called recursive proving, where you can actually see how you can reduce the time that it takes to do computation. And also the benefit is that, even right now with the Starknet with a centralized sequencer, you have pretty much the same level of security as Ethereum because the security is given by the CK proof. It's not given by decentralization. Decentralization in this area is going to be beneficial for censorship resistance, but not for security. So a network like Ethereum, you need to have a lot of different nodes operate independently to have credible security, because that's basically what it's derived from. In the case of a Starknet, security is just only given by the math behind the CK proof, not by decentralization. It doesn't mean that Starknet is always going to be centralized. Actually, the plan for Starknet is to also decentralize, but we won't need to have 10,000 computers to centralize. We only need maybe 100, right? Because it's for censorship resistant, not for security. Hopefully that clarifies. Okay, moving on. I'll leave the questions to the TAs and to Robert. Another example of using Cairo, right? I give you the example of the space exploration, but what about a more, current scenario like machine learning, AI? Imagine that your boss comes to you, you're the engineer, so you know what? It will be great if we have our own AI model trained on our own data, that we have a lot of private data, so we can have some kind of an edge against the competitors. So can you do that? Can you train a model for me with our data? I don't want this to be public. I just want to be in-house. And you, as an engineer, say, sure, yeah, it's technically possible. I can take some open source model, find a way to train it with this data. I don't know, that's possible. But the issue is that to train this model, you need a lot of computing power, right? Again, you have to delegate the computation to someone else because you don't have a powerful computer in your company to do that for you. Maybe you don't know how to do the training, right? Maybe that's also the issue. So what you can do is just basically you talk to company B, who has the expertise of how to do this training. He has the infrastructure. Say, hey, if I give you the data, can you actually train this model for me and give me the trained model? Say, yeah, sure. I mean, you can use something like Python and train the model with the data and give the model back. You say, oh, okay, that's cool. But how do I know that you actually trained that model with my data? I mean, you can do some queries to verify that it's answered correctly, but training is expensive. Maybe company B cut some corners. They left some data out just to make it as cheap as possible, prove the profits. It's going to be very hard for you to know if they actually use all the data that you provided to them. So that's the issue of using a traditional language, like in this case, Python, like in the example was Rust. Now, if you rerun this scenario, but now company B is going to use Cairo to train the model. So now what's going to happen is that not only they give you the model back, they give you the cryptographic proof that attests to the validity of the computation. So you'll know that that model, because you can verify that proof independently, that model was trained exactly with all the data you provided and nothing was left out. So again, you don't have to trust that company besides you can verify independently. You have certainty that the output is exactly what you were expecting it to be. That's another scenario where Cairo could be useful. And again, none of these scenarios talk about blockchain at all. We're gonna talk later about why Starknet and how we use this technology on the blockchain, but you can use it in this situation as well. So some of the features of Cairo, first of all, as I've been hinted, it enables what's called verifiable computation, that you can derive a proof of the execution and you can verify it. Cairo runs on top of the Cairo virtual machine. And that is important because if you come from Ethereum, you probably heard about the Ethereum virtual machine. We have a different virtual machine because it's fine-tuned for Cairo and for zero-knowledge proofs. Now, the syntax of Cairo is inspired by Rust. It's not exactly the same syntax. It's not Rust, but it's very similar. So if you know some Rust, you will find at home at Cairo. And if you don't know any Rust, when you learn Cairo, you will be learning a lot of Rust at the same time. It's because they have similar ownership model. They're also strongly typed. They are based on traits. They have macros for meta programming. And as I mentioned, you can use it on a Starknet or outside of a Starknet as well. But the best of all, in my opinion, is that you can take advantage of all these technologies of zero-knowledge proofs, and the language is going to abstract away all the complexity for you. So you can just focus on the logic of your program, which is not the case for other languages that generate CK proof like Circum. Circum, you kind of have to know some idea of how the things works in the hood to be proficient in it, not with Cairo. Jeb, Tamuna, a similar ownership model? Yes. So if you know anything about Rust, one of the core features and the reason they don't have a garbage collector, which makes it very fast, is because they have this called thing ownership model, basically how memory is allocated and deallocated during execution. It's a more advanced topic. It's mostly people who come from Rust will understand what that means. But this Cairo has the same model as well. Just answer this live. Cool. A few examples, just to have a taste what the language looks like. This is how you create a custom type in Cairo. You use a struct, you give it a name, you define the properties, and then you define the types. As I mentioned, Cairo is a strongly typed language. So in this case, they are unsigned integers of 64 bits. You have unsigned integers of 8, 16, 32, 64, 128, and 256. If you want to define reusable logic, you will use a trait. Again, very similar to what you do in Rust. I call this example, you have a trait called shape geometry, and then you define the signature of just two methods, boundary and area. Again, I don't want to get into too many details. We're going to have session 3 to learn more about Cairo in detail, just to give you a taste how the syntax look like. If you know any Rust, very similar again. But then you have some deviation from Rust. In this case, when you actually implement the logic of the trait, it's a bit different from how it looks like in Rust. But again, if you have any experience programming, you're going to feel pretty much right at home seeing this type of syntax as well. People are asking, what if you don't know Rust? Okay, well, you're going to be learning a bit of Rust while you learn Cairo. So that's a 2 for 1. We don't expect people to know Rust when we learn Cairo. I just make a lot of references to Rust because the syntax of the language was clearly inspired by Rust. So I just make this connection for people who know, but it's not a requirement.
David, we have a question, and the question is from Adrian. What drawbacks does Cairo have?
Compared to what? To Rust?
I guess as a general programming language, there's no other information on this.
The only drawback that I can think of is that the way strings are managed these days, they don't support Unicode. So you can only use strings that are ASCII, right? Which is annoying sometimes. For example, there's a game that I like to play called Influence that's built on Starknet using Cairo. And one of the limitations that when you want to give it a name to one of your characters, you're going to use special characters. For example, in Spanish, we have some characters that they don't exist in ASCII. So I can't, right? Because it's not supported by the network. The language has been around for, I think, 3 years, maybe right now. Has evolved a lot. Actually, just a new version of the language came out a few weeks ago. It's going to be activated on Starknet very soon. So the language keeps evolving. Anytime you find something that is missing, you can just open an issue in the repo and say, hey, I would like to have this feature. But programming wise, that's the only one that I can think of that I wish we had. I don't know, Robert, you have something else?
I guess it's mostly the onboarding because it's a total new language, and then people would have to invest time. But it definitely helps if you know a programming language, and it's easy, especially like if you know Rust, it's super easy to pick it up.
Yeah, I think it's also, I will say it's a steeper learning curve that, for example, something like Solidity. I think Solidity is a bit easier to learn. Just because Solidity looks a bit like JavaScript, which is a very popular language. Rust is a beautiful language, but it's still not as popular. Not that many people know Rust compared to knowing JavaScript. And this, the way you share logic is not through inheritance, like you will have in Java or JavaScript, is through traits and implementations, which is a different mental model, but in my opinion, it's more powerful because it's more flexible. So I don't see it as a downside, I see it as a positive, but you have to learn how to use it. Okay, Robert, you're answering one. You're gonna see the other one. Mohammed is saying, for writing CK programs, why would I pick Cairo and not Circum? Are Cairo programs as efficient as Circum programs? I actually did a talk comparing Cairo and Circum earlier this week, and the benefit is that, I mean, if you really know Circum, I think you can create circuits that are a bit more efficient than Cairo, but not by much. Like the Cairo CPU, which is basically a set of CK circuits, are being highly optimized at this point. That I think will be a very close competition, but you get so many things out of that. That, for example, if you ever try to use Circum, it's not an easy language to learn at all. Also, it's not a Turing complete language. There are things that you cannot build with Circum. Cairo is a Turing complete language. So you have way more power. Yes, maybe you can leave a bit of performance compared to Circum on the table because Circum is just, you create the circuit right away. Cairo, on the other hand, you execute the program on a CPU that is actually the CK circuit. It's like a general purpose circuit. But the CPU also has dedicated, let's say, ASICs or virtual ASICs for more complex computation like hashing or ECDC operations. That's how you get the actually very high performance. But I don't have a benchmark to tell you how much the difference is. I'm willing to sacrifice a bit of performance if I get a much better economics for the same purpose. Let's see more questions. If Fianji is asking, what are some of the existing live instances of Cairo application outside of Starknet? Oh, okay, good. Let's see. We have Herodotus. Not this one, Starknet. You can take a look at Herodotus. That is a great example, in my opinion, because basically what they're doing, they are proving Ethereum and submitting the proof to Starknet. So, I mean, yes, it's used in the context of a blockchain, but it's used as a general purpose programming just to prove a language, or sorry, to prove a blockchain that is not meant to use ZK proof, but they do that. I think there was something also on Zero Sync and Bitcoin. I don't know if that's still a thing. Sync Bitcoin. Similar thing. They're proving Bitcoin using Cairo as well. So you can synchronize a node in a trustless way in just, I think, minutes instead of weeks, as it normally is when you try to synchronize a Bitcoin node from the beginning to derive the UTXO, and you get the same trustless guarantee. So those are the two examples that come to mind very quickly about how this is used. Oh, I mean, that's the one that I know that you can use today. I know people building more tools. I know someone is building almost like a map reduce platform based on Cairo, so you can do like a more heavy computation that requires a lot of threads because Cairo is single thread, but with the right architecture, you can process things in parallel. And they're building that. I forgot the name of the company, but those are examples that come to mind. I don't know if any of you, the TAs or Robert, if you know any other example, let me know. Okay, so I answered that one. Idris is asking, what does it mean Cairo is a Turing complete language? Basically, a Turing complete language is a language where you can have loops. It seems like a small thing, but if you don't have loops, writing any program is so hard, almost downright impossible. And a very good example of a language that is not Turing complete and creates a lot of limitations is actually Bitcoin script. Bitcoin script is very interesting, but try to build something complex and with Bitcoin script is impossible because it's not Turing complete. Most languages that you know and love are Turing complete, almost all of them, like Rust, JavaScript, Python, Cairo. All right, back to the slideshow where Yeah, so this is just a taste of how Cairo looks like. But now, how does it look like when you actually use Cairo to create a smart contract, right? Again, I'm not trying to go deeper into this. We're going to have session 4. We're going to go in detail. We're going to build this step by step ourselves as smart contracts in Cairo. But just for you to have an idea. So in Cairo, we use heavily what's called macros, right? And these things here, this is a macro, the storage is a macro. And what this label is a feature called meta programming that is also present in Rust. Meta programming is basically that with macros, you can enhance your code. And for example, here, you can take a regular module and you turn it into a smart contract. Or here, you can take just a regular struct and you turn it into the storage of the smart contract. So here's how you define the storage of the smart contract with the struct, and the properties are the values that are being handled by the smart contract. When you want to define the public interface of the smart contract, you use a trait similar to an interface in some regard. You have some generics. Again, not trying to go deep into this, just to give you a taste of what it looks like. You define the methods your smart contract is going to support. The first argument that get passed is the state of the smart contract, and then any other argument that you're expecting. Is it like Python decorators? Yes, I think it's a similar concept. And then, this is only the public interface, but then you have to implement, okay, so what is the logic behind the interface? You do that with an implementation. So again, with a meta programming, you say, okay, turn this implementation into an ABI. An ABI is a concept of smart contracts where you say, hey, this is my public interface that you can use to talk to me. And you can see this is how you write data to storage, and this is how you read data from storage. Again, it's just a taste. We're gonna get back to this in detail in session 4. Okay, to summarize this section, so why Cairo? So first of all, enables verifiable computation, right? The fact that you can prove and you can verify the execution. And the proof is about computation integrity, that the thing happened exactly how it's supposed to be, right? And no one tamper, malfunction. You can do this verification of the result without having to re-execute the program. That is very important. You only have to verify the proof. The verification is very cheap because re-execution is expensive. It's a very powerful and flexible language because it also inherits features from Rust, prevents cheating and malfunction, and keeps a supercomputer on. So it's all about why Cairo. Let's see why. So if you know anything about blockchains, and if you don't, it's the moment to learn it. At any given time, there is one single computer in the network that is going to have the chance to propose what is the new global state of the network, right? And you do that by basically taking a bunch of transactions, you put into a block, you execute them, and you propose, hey, this is the new global state, right? But then the other nodes on the network, in the case of Ethereum, they're not going to trust what you're saying, right? What they're going to do is going to say, okay, this is a block you produce. Let me re-execute the same block with all the transactions and verify that I'm also getting the same number, 42. This is where the whole re-execution happened and the whole consensus happened to see if someone is cheating. So if they all come to the same conclusion, or at least the majority of them, they say, okay, cool, this is a valid state, this is a network. But you can see here that although it's very robust, because cheating is very difficult, downright impossible, it's not very efficient because the same transactions are executed over and over and over around the world in tens of thousands of machines. So you can see how this, in terms of efficiency, is not great. Now, compare that to how a Starknet works. Because in the case of a Starknet proposes a block. In this case, Starknet proposes a new block for a Starknet. It doesn't propose blocks for Ethereum. But they say, okay, if I execute all these transactions in the block, the new state for a Starknet is going to be 42, let's say. Not only is it going to give you that claim, it's also going to give you the proof, the ZK proof of that execution. So now that proof, that new state and that proof is going to be sent to it. And now the Ethereum validators, they don't have to re-execute all the same transactions that Starknet did to just say, yes, we can confirm that it's a new state of Starknet. They only have to verify the proof that is given. And that verification is only a fraction of the execution of all the transactions in the block. And only by successfully verifying that proof, they will have certainty. They're going to say, yes, we agree that is actually the new state of Starknet. It's 42 because we verified the proof, all of us independently, and we agree that it's correct. So even though on a Starknet now it takes a bit more effort because not only you have to compute, you also have to generate the proof, right? It takes more computing power. But overall, as a whole system, the system is much more efficient because now you don't have to re-execute the same transaction over and over. When it gets re-executed, it's just the verification of the proof, which is only a fraction of the effort. That is essentially why Starknet is so cheap, why it has the same almost the same security guarantees, or how do we use Ethereum for security? How do we manage to scale? Now, how much is the difference? How efficient are we talking about? If we compare the execution, for example, if the amount of work done by the sequencer to come up with this new state, Starknet is this amount, let's say this blue thing, the amount of work that the validator on Ethereum has to perform to say, yes, this is correct, is very small. It's only log square of x. This is polylogarithmic. It's a log base 2. If you put it on a chart, it's easier to see, right? The blue line will be the effort of the sequencer just executing the transactions to come up with a new global state for Starknet. And the yellow line will be the effort for the Ethereum validator to say, yes, we have verified that it's correct. So the bigger the gap between these two, the more you actually gain in performance and the cheaper it gets. Someone saying there are some issues with the screen. Anyway, Robert is on it. Yeah. So you can see that this is how, I say, it's only a fraction. This is the polylogarithmic. So the bigger the gap, the more we actually save in performance. Now, this is just the base case. One thing that I haven't mentioned that is that we have a thing called proof recursion that makes this gap even wider. So we gain even more in performance. This is a feature that exists in the prover you use for Starknet, proof recursion. We're not going to get into that, it's more advanced. But just the base case, you can see the benefits of it. Now, validity proof is to computation when the zip algorithm is to file size, right? It is a type of compression. With Cairo, you actually compress computation. With zip, you compress file size. It's a good analogy to have in your mind of the benefits. Okay, so what are validity proofs? So validity proof is a use case of zero knowledge proofs. You probably hear about the term a lot in the context of Ethereum. And what it does is convinces a verifier on layer 1, in this case on Ethereum, of a new layer 2 state, in this case Starknet. I'm going to convince you that it's actually a new state without revealing all the details of the transaction that happened on layer 2. And that is very important. This doesn't make layer 2 transactions private. That doesn't make Starknet private. What it means is that we have to share less information to convince Ethereum of the new state. And by that, we actually use less bandwidth time. It makes verification more succinct, more efficient. And because we use validity proof on a Starknet, we like to call our layer 2 to be a validity rollup instead of being a ZK rollup, just because ZK gives the impression that it's about privacy, and we are not about privacy. Starknet is based on ZK Starks, not in ZK Snarks. This is people who kind of know about both terms. These are two families of zero knowledge proofs being used. Funny enough, Starknet is the pioneer of Starks, and initially we were the only one using Starks among all the other projects on layer 2. These days, almost all of them are using Starks as well. So this is actually becoming the default standard. And what you get with validity proof is efficient proving and verification. Let me see some of the questions. Mohammed asks, is a proof generated for each transaction or for each block of transactions? That's a great question. These days, it's complex to answer, but I will say that currently each block have a proof, but then very soon, in a couple of weeks, it's going to be multiple blocks. And not only that, the single proof that goes to Ethereum not only is proving what's happening on the Starknet, it's also proving what's happening in all the StarkX apps as well, all in one proof. And that's thanks to proof recursion. Okay, Robert is answering this question. Okay, cool. So I talked about Starks and Snarks. And if you don't know, these are two families, right? Zero knowledge proofs, Stark being the one used by Starknet. So how do you compare it? So first of all, the effort to verify a Stark proof is polylogarithmic, right? I showed you the graph, the yellow line. In the case of a Snark, it's actually constant, which is an interesting feature, right? It doesn't depend on how complex the underlying computation is. The effort to verify the proof is always the same. Now, the size of the proof that we send to Ethereum for verification, in the case of a Stark, is like a 400 kilobytes. In the case of a Snark, it's like a 300 bytes only, right? So you say, well, you know, Snark looks much better than Starks. Why do we actually choose to use it? And the reason is because, because creating the actual validity proof is 10 times more efficient with Stark. And that's where most of the computation is actually going, in creating the proof. So if you want to optimize the system as a whole, you really care about this. And with new advances on the prover, very soon we're going to have, this is going to actually be 1 to 1,000. It's going to be 100 times even more efficient than it is today. And it's going to come actually fairly soon. Another benefit is that you don't need a trusted setup for the system to work, which in the case of a snag, you do. And the trusted setup means that the prover and the verifier, they will have to share a secret. And if that secret gets leaked, the whole system is compromised. That is one of the issues with snarks, right? You get, nice performance, but the security is lower. And also, the snarks are deemed to be quantum secure. Snarks are not. Actually, the moment a sufficiently powerful quantum computer comes online, they're going to be able to crack snark, basically submit a fake proof that passes valid. But to our knowledge of the community, it's not yet possible to actually do that for Stark. So we are deemed to be quantum secure as well. So, very forward-looking or future-proofing technology. Now, another common question I get asked when I go to events is just, why do we choose the Cairo VM and not the EVM, right? And the reason is basically when you go the CK EVM route, like CK Sync, like Polygon, you gain incompatibility, obviously. Now you can take the same Solidity code and deploy it to your CK EVM with little change. That's great. But what you're leaving on the table is performance, because the EVM was never meant to be used in the context of zero-knowledge proofs, right? It was meant to be used in the context of a more traditional computer architecture. So try to make it compatible. You actually introducing more abstraction layers and more friction in the system. We decided to just be very, forward-looking and say, what if we just do everything just from the ground up, optimized for zero-knowledge proof? How far can we go? So we have a much higher ceiling for performance, right? Because now we don't need to really think about compatibility. Actually, you will have to rewrite your Solidity smart contract to Cairo if you want to deploy it to Starknet. But what you get is that you get way more performance. So that's the reason why. It was very painful at the beginning. I remember when I joined, the ecosystem, like Cairo has evolved a lot. In the beginning, it was a horrible language. All the tooling was broken because we have to develop evolve the language. We couldn't reuse anything that existed on Solidity. But now, these days, all the tools have matured and they're very good. And you're going to see that when we go to session 4 and we start actually building something. This is a perfect time to actually learn, because the past experience of grinding your teeth to build Cairo is no longer. It's actually very nice. Talking about finality, on Ethereum, you'll say that a block is final about 6 minutes the moment it's created. In the case of optimistic rollups, like in the case of Arbitrum and Optimism, you actually have to wait for a full week to get on layer 1. So basically, when you want to withdraw an asset from layer 2, from Optimism or Arbitrum, in the base case, you have to wait a week to withdraw the asset back to Ethereum. And the case of a Starknet, the layer 1 finality is actually about 10 hours. This is the frequency that proofs are verified on Ethereum. So if you want to withdraw an asset from Starknet to Ethereum, that's how long you have to wait. It seems like a lot, but compared to the rollups, it's a fraction of the time. Now, finality on layer 2, like when you use applications to interact, is actually very short. It's very soon, it's going to be 2 seconds. Let's say this is an update that is coming, I believe, at the end of August, because right now it's actually more like 10 seconds or 30 seconds, the confirmation for layer 2, but it's going to get to 2 seconds very, very soon. So it's pretty fast. If you want to see some of the performance of Starknet, how it's doing, especially because we use something called account abstraction, comparing performance is a little bit tricky. Let me maybe just jump into the block explorer, like Starkscan. Starkscan. So let me share the link here. There are 2 block explorers. You have Voyager, and increase the font size. Dog is going a little crazy. All right, I have these 2 block explorers. Let's see this one. If you want to see some performance, you go to click here, and you can see this is transactions per second. What I want to make the point, just a comparison that I found interesting earlier today. Steps per second. Is this the one? Max steps per second. Okay, yeah. Let me set up correctly. Okay, so here we're looking at the maximum amount of transactions per second per day. You can see that maybe it had a peak of, what is it, like 45, no? And sometime in February, I think that was during, anyway. You see, oh, it has gone down a bit, right? I mean, market has been choppy, but actually the amount of computation being performed is measured by how many Cairo steps the sequencer is actually performing. You can see that it's actually going up because what's happening is that on a Starknet, you can have way more complex computation. So now we're having less transactions, but each transaction is getting more and more complex. It's using more and more computation. So this is using like more advanced use cases. I'll give you an example. In this game, Influence, that I play with Robert as well, there's a way to send a spacecraft to one asteroid to another. And the whole calculation of the trajectory, similar to example, is actually done on chain, on a Starknet, and using real orbital mechanics. And that is a very complex computation that you can actually do on chain because you have all this computing power. And also another benefit of a Starknet is that you can execute multiple transactions or multiple user operations in a single transactions. You're going to see that a little bit more when we get into smart wallets, but it's a feature very interesting. Alexander is asking, why is a Cairo step? Think about a Cairo step like a CPU cycle, but in the context of CK circuits, right? So, or flops, like operations per second. So what I'm showing you is that even though transaction is going down, the average complexity of the transaction is going up, which makes the system is actually working harder because we're more complex computation. So stats, what I want to show here is the comparison that yes, TPS is like 47, the peak, but the user operations is pretty high. I think we actually have some tests on, let me see. I think there was some stress test we did in Sepolia in preparation for the, or maybe it was in the integration. Oh no, here we are. Very recently, August 13, Starknet did a test on Sepolia on the Starknet testnet, just to see, because there's a new update coming up to mainnet in a couple of weeks to say, and this update is gonna increase the capacity, how much performance. And you can see that the test actually they did 583 transactions per second. So this gives you an idea of the capacity that we're gonna have in a few weeks' time. That's pretty cool. I heard about that, but I didn't see the numbers until now. Question from Pashal, is it possible to batch multiple transactions into one? Yes, it is actually possible. It's called all right. So to summarize, why Starknet? First of all, the whole tech stack is optimized for zero-knowledge technology, which gives you more computing power by paying less in gas. The system is secured by Starks plus Ethereum because we send the CK proof or the CK stack to Ethereum for verification. It gives you a very powerful programming language in the form of Cairo. It's very battle tested. Many people don't know, but Starknet has been live on mainnet for years now. So in the 2 or 3 years been on mainnet, it has secured about $1 trillion in transactions so far without any. And if you want to withdraw assets to layer 1 from L2 to layer 1, it's about 10 hours. Compare that to 1 week for optimistic rollups, and there's no trusted setup. So it's a much more secure system. So let's talk about smart wallets. What is a smart wallet? It is a wallet that allows you to, for example, sign transactions using Touch ID or Face ID, where you can execute multiple operations in a single transaction, right? We touched on this a bit earlier, saying that, like the user operations. And on a Starknet, every single wallet is a smart wallet. This is relevant because when you go to Ethereum, you can see that there's a combination. Most wallets are what's called EOAs or externally on account. Some of them might be smart contract wallets, but in Starknet, every single wallet is a smart wallet. There are no EOAs. And this is built using a pattern called a CAN abstraction. I don't want to go into too many details on that, but just know that is the reason. There are 2 main providers for wallets. You have Argent. If you see, for example, this is Argent. They both provide a wallet as a browser extension and as a mobile app as well. This is the case of Argent, and this is the case of Bravos. Funny enough, my plan today was to show you Bravos in particular, how to set up the browser extension and then how to import that into your mobile phone so you can enable a hardware signer. And I realized it just yesterday, somehow the app disappeared from the App Store. I got in touch with the developers. They're trying to figure out what happened with Google. So we're just going to go halfway what was planned. Maybe we can complete the exercise next time. So exercise number 1 is to install the Bravos browser extension in your browser. You can also use Argent if you prefer. create an account on mainnet. You're gonna share the wallet address with us, and we're gonna give you 10 Stark tokens so you can get started, because we're gonna have to use, we need to have a wallet for future sessions as well, because all the deployment, all the interaction, we need to have a wallet. So this is the moment to do the setup if you don't have one already. And what I'm gonna do is to show you how to install the wallet. Let me first uninstall what I have so I can show you from scratch everything that remove. So basically, you can either go directly to their website and find the link, or if you're in a Chrome-based system, you can just search in the extensions and you search for Bravos and you install it. Right? You say add to Brave. I'm using Brave. You can use Chrome. You can use Firefox. You can use, I think, Edge as well. I'm gonna pin this so it's always visible. All right. So this is the wallet installed as a browser extension. I'm just gonna create a new one, and I'm just gonna give you a password. You give it whatever password you want. It's only to unlock the wallet. Make sure you back up your seed phrase. I'm just using this as an example, so I don't care too much. I'm just gonna destroy this wallet after we end today. So I'm just gonna pretend that I copy, but I didn't, but you should copy some. And that's it. We have a wallet on mainnet. So now what I need for you guys is I'm gonna launch another poll. Polls and quizzes. Share your wallet bunch. So please, I enable a new quiz just for you guys to share the wallet address. And the wallet address is basically this, right? So you copy here and share this amount, because that's how we send you 10 Stark tokens to get you started and to show you how to, complete the setup and do more advanced things. We are back, and we're gonna keep talking about, please don't keep sharing your wallet address. We cannot just do it again. You're gonna have to find tokens some other way. You can just bridge assets. If you want to bridge some assets, you can go to Stargate. This is the official bridge. This is how you can actually bridge some ETH and then get some Stark tokens. You can use this bridge, and you can use something like Avenue to buy the Stark tokens. This is that DEX. There you go. All right, back to the slides. So hopefully by now you have some coffee with you, or tea, whatever you drink, because we're gonna talk about some of the features that are enabled to any smart wallet on a Starknet, and because every wallet uses a smart wallet, all of them gonna have this feature. One of them, you can do very complex interactions, and that is because sometimes complete an action requires multiple steps, and those steps are usually known as user operations. So imagine, for example, if some action, for example, if you go to a decentralized exchange, normally you have two things you have to do. You have to approve the usage of the token, and then you have to do the swap, right? Normally, those are two independent transactions. Now, when you send those transactions, which are just two steps in the same process, some people might expect that the two transactions get included in the same block and in the same order that you started them, but that's not the case. Actually, they can be included in the same block, but maybe in different order with some transaction in the middle of someone else, or they might actually get included in different blocks, right? There's no guarantee. And the issue with that is that this could be exploited by what is called MEV, maximal extractable value. People who are actually able to do some sandwich transactions in order to affect you financially in some way. This could be very small extraction of value, could be very large, depending on what you're trying to do, right? So you need to be mindful of the situation on a regular blockchain that doesn't implement multiple. Now, on a Starknet, because we are able to bundle transactions together into a single transaction in a feature called multi-call, what's happened now is that now these two steps that you perform, they actually get combined into a bundle. And that bundle is actually included together in the same block and in the same order that you execute them, right? Which in some capacity protects you against MEV, at least people getting transactions in the middle, because now you have the guarantee that all these steps, they're going to be executed in exactly the same order that you define, and no one can get a transaction in the middle, right? And they're going to be all in the same block as well, which is important. So I mentioned that all of this is possible, smart wallets, thanks to a feature called account abstraction. And account abstraction is basically the decoupling of the signer from the account. Because in externally on account, like on Ethereum, those two, let's say, things are the same, one and the same. Now, the signer is the device that signs the transaction. Could be your phone, to be your computer. It identifies the user using a private key. And then you have separate the account. And the account is a smart contract on a Starknet, which is the thing that actually holds the assets, your NFTs, your ERC20. And one of the goals of the account is to verify the signature, verify that it was signed with the private key of the signer that you control. And also one thing that it does is that it executes transactions with multiple. Takes this bundle and makes sure they're executed in the same order and as a single transaction. So that is a kind of abstraction at a very high level. Now, in practice, how does it look like? Well, when you want to interact with some smart contract on a Starknet, it all starts with the signer. If you have like the wallet on your phone, for example, or the extension of your browser, your device is going to be the signer, identified with the private key. The account contract is the smart contract that is connected to your wallet. So it's two things working together. And that smart contract needs to comply with a specific interface defined by the SNP 6, just some standard. Basically, it has to comply with some trait, right? To execute, how transactions are executed, how the signature is validated, in a way to, if I give you a signature, you're going to tell me if it's valid or not the signature. This is more advanced. I don't want to get into many details. Just take away that for every wallet that you have, there's a smart contract on a Starknet connected to your wallet, right? And that's called the account contract. Now, when you want to interact with some other smart contract, the signer sends a transaction to your account contract, which is going to do the interaction on your behalf on chain after verifying that you are actually what you claim to be. It's going to verify your signature. So you're going to say it's going to work as a kind of proxy, on-chain proxy for you. Every single wallet has an account contract associated that just proxy all the requests. And now that we know this fact, we actually going to see it in your wallet. Let me see, there's a question here. MEV from Raj. Multi-call Starknet prevents reordering of blocks. Validators can reorder blocks. Block reordering, they can reorder blocks for sure, but you have the guarantee that your transactions are executed together in the same block. But the block ordering, you don't kind of control that. Right now, because Starknet has a single sequencer, it doesn't happen, reordering doesn't happen on layer 2, but it could happen potentially on layer 1, right? If, for example, there's some issue with the validator, I think it has happened with some upgrades, but yeah, the multi-call is not going to save you from block reordering. Okay, so I talked to you about account abstraction, and I want to show you the account contract that's behind your wallet. So what we're going to do first, now that you have hopefully your wallet with some 10 star tokens, is to interact with a smart contract. Very simple smart contract that I deployed yesterday. I'm going to share the link in the chat. So if you click the link, you're going to see my super simple smart contract that you can interact with directly on a block explorer. And what I'm going to do is just connect my wallet. In this case, I have Browse. I'm going to connect Browse. Approve. And I'm just going to execute the increase counter function, which is just basically increase by 1 some internal value for a counter, right? You just click the button right. My wallet pops up. I click sign. All of this happening on mainnet, right? Using the 10 star tokens. You can see that the fees are very low, like less than a cent of a dollar. This is how fee Starknet is. And yeah, so in the meantime, let me see some questions. Bogdan asks, can signer be connected to multiple account smart contracts? Potentially, yes. Potentially, yes. Every wallet provider, they give you different features. You can have, for example, a multi-sig, which is going to be native, right? It's not going to be something different from a regular smart contract. I think Bravos and Argent, they both have multi-sigs that you can use. And yeah, I don't see why you can use the same private key as a signer for multiple wallets. I don't know if the wallets support that out of the box, but if they don't, you can build your own as well. Okay, a transaction went through. So if I now read the value, 27, okay, all of you are interacting. That's great. But I wanted to show you, it's not only just using the wallet for the first time, is that if you go take a look at the activities, you're going to see that there are 3 things that happen here, right? Control this. The first one is just, I got the 10 star tokens. You all have that. But look at there's 2 transactions, account deploy and increase counter. I didn't call account deploy myself, right? I did call the increase counter. What happened is that all these wallets like Bravos and Argent, when you execute your first transaction, the first thing they do under the hood is to deploy the account contract that's going to be connected to your smart wallet. This is what happened here, right? So this is not a multi-call. This is actually two different transactions that are happening. But now, if I see the transaction and I go back, actually, no, let me see it a different way. If I copy the address of my smart contract and I search for it, yeah, it takes a while for this to, for the indexer of the block explorer to update. Let me try Voyager. Just trying to show you this, the account contract of my wallet so you can see yours as well. Where's the search bar here? No, here. Nothing yet. Okay. Yeah, the slowness is just the block explorers reindexing new data coming in this case, reindexing this new smart contract or account contract that was deployed on the system. So let me get back to that in a moment. Let's see if there are some questions in the meantime. Okay. We're going to do this checking the Explore account contract. Oh, let's check the transaction details. That we can do. If I go back to activities and I click the increase counter, I can click in the transaction ID. Let me zoom in. What is it? Forgot how to zoom in. Oh, there you go. We can see that we pay 0.0011 star tokens, which correspond to less than a cent, like a tenth of a cent. I don't know, is that a penny, maybe? And if we click this, we see the details of the transaction, and you can see the life cycle of this transaction, right? This is when the transaction got received by the sequencer, by Starknet. This is when it was added to the what's called the pending block, session 2. You're going to see more of this in detail. This is what it got accepted on layer 2. This is the layer 2 finality. And you're going to see it's going to take a while until it's accepted on layer 1 because it takes about 10 hours for proof to be combined of all the transactions happening on Starknet and be verified on Ethereum. But this is enough accepted on layer 2 to continue working on the blockchain. Let's check it again. Nothing yet. So let's keep moving forward, and then I go back. Just give it some time for this to re-index and hopefully information show up one more time there. Nothing yet. Okay, back to account abstraction. So signature verification. The idea with having this account contract is that now you can program the logic of how you want signature to be verified, right? And this happened in the account contract. And this is very powerful because this is what enables things like having you can think like a single signer, which is what we have right now, but you can have a multi-sig, right? Which is all native to Starknet. You can have a hardware signer, so you can sign with your phone, with your secure enclave. You can have social recovery, which means that in case you lose access to your seed phrase or your wallet, you can define guardians like your family and friends that they can combine or give you access again to your wallet. You can have session keys for gaming, super important, so you don't have to sign every single transaction when you play an on-chain game. All these things are possible on a Starknet, and actually you can do it, enabled because of flexible signature verification. Multiple ECDSA curves are supported. You have the Stark friendly, you have the Ethereum elliptic curve, and you have the standard elliptic curve, right? This is a more advanced use case in case you want to build your own wallet. My favorite feature, probably because of security, is that when you have a kind of abstraction, now you can use the secure enclave of your phone. It basically means that you can turn your smartphone into a hardware wallet. What it means is that every modern device, every smartphone, has two main systems. You have the shared system. That's where your application you install live when the operation system leaves. They have some shared processor, some shared memory, which is great for many things, but it's not the most secure place to be because of this shared memory. So some malicious application that you install might be able to snoop in some memory addresses that don't belong to them. In contrast, there's another system on your smartphone that is the global name is the Trusted Execution Environment. No, Trusted, the TEE. Yeah, Trusted Execution Environment, also known sometimes as a secure enclave, which is a subsystem that is dedicated for security features. And it will have its own processor and it has its own memory. And it only does a few things. For example, it generates random numbers. It handles all the cryptographic keys that you use, like your private keys, for example. It has hardware dedicated to sign transactions or to sign any message using that particular elliptic curve that is supported by Starknet. And this is what allows things like keychain, Touch ID, or Face ID, right? When you unlock your phone or for example, your bank, right? Sometimes you use your bank, your phone, and to get access, you use your fingerprint or your face and the thing unblocks. that is taking advantage of the secure enclave or the TEE of your processor. So now, because Starknet support this particular elliptic curve, we can make use of that. Wallets that you install on your phone that enable hardware signer, they actually use the secure enclave for the private key. So you have a much higher degree of security. I use the name secure enclave, but the global name is TEE, but different providers have different names. If you have a Google Pixel, we call Titan M. If you have some Samsung phone, it's called Knox. And if you have any ARM-based phone, it's called Trust Zone. This is a very common thing. It also applies for laptops. Many laptops also have some secure subsystem that you take advantage of. So to summary about the smart wallets, you get better UX than regular wallets. You have things like social recovery, session keys, blah, blah, blah. All this is enabled by account abstraction. The feature that decouples the signer from the account, and every account will have a smart contract associated with it. An account is a smart contract with a specific interface that I mentioned that has the execute, the validate, and the is-valid signature. It supports signing transactions with different elliptic curves because it's programmable, and we support multiple elliptic curves. And on Starknet, every single wallet is a smart wallet. There are no externally owned accounts. So let me go back to try again to see if I can check my account contract. Finally, let's see. Yes, finally, it's available. All right. So what I want to show you is the code. So this is the smart contract that acts as the account contract for my wallet in particular. If I see the code, read right. Okay. This is the public interface, right? And you can see here some of the method that I mentioned is valid signature, or yeah, it has many more. Not all of them are public, or the validate deploy, validate declare. But this is the account contract that is associated with my particular wallet. And only I can control it because it's connected to the private key of my wallet. So you can check that on your own. Basically, you go to your wallet, copy the address, and you paste it on, could be in Starkscan on Voyager, and you can see your account. And here you can keep track of all the transactions that happen from your account and events and all that, right? Every smart wallet has an account contract, which is a smart contract. I wanted to go a little further with this exercise today. For example, I wanted to show you how to bring that wallet that we created back into the mobile app and how to enable hardware signer. We won't be able to do that today just because this issue that I found just yesterday that the wallet is not currently listed on the Play Store. We have an Android phone. And so maybe we can leave it for session 2 at the beginning to show you that. Okay, Bootcamp is asking, why are there multiple curves? Why not only one of them? And the reason is for flexibility, right? Because one of the limitations on Ethereum is that it only supports one particular elliptic curve, which is the K1. But that elliptic curve is not supported by your smartphone because it's not the standard elliptic curve, which means that you cannot take advantage natively of the secure enclave because there's a mismatch of elliptic curves. The starting what it gives you is flexibility, so you can use different devices to sign transactions for your wallet. Mohammed asking, is this similar to a passkey? Yes, passkey is basically the name for usually browser-based applications. Like, yeah, it's similar to passkey. Just secure enclave is more like for smartphones. Passkey is usually associated with browser-based apps, like your browser extension for the wallet. Drew is asking, what are the concepts of elliptic curves? Ooh, that's I'm gonna skip the question because that's very deep and very foundational knowledge of cryptography. But I encourage you to take a look at YouTube. So some basic knowledge of elliptic curves, at least some of the properties, not really how it works to advance, but if you know some of the properties, that is going to help you a lot in your journey to Web3. Dulfat asks, why wallet on a Starknet is not interoperable? And will that be possible in the near future? It's interoperable. It's not. Why it's not? It's just because, as you can see, every wallet needs to have a deploy account contract on a Starknet to work, right? Which is not something that would work on other chains, right? They all have the different ways to work. So no, what you can do is just deploy. You can bridge assets, but I don't think you will be able to use the same wallet anywhere else. Mohammed asks, can we use MetaMask for last exercise? I think you can. There's a thing called MetaMask Snap. I never used. I heard that it's possible, but so basically it's like an add-on for MetaMask that will give you support for Starknet. If you tried, let me know if it actually worked. I never tried, but it's potentially possible. Yeah, Elif, if you don't find Bravos app in your Google Play, yes, this is the issue that I'm discussing. Just yesterday, for some reason, it got removed. I let Bravos, the team, know that it's happening, so they're talking to Google to see what happened. It will come back soon. So for next session, we expect that to be fixed, and we can just do what we're supposed to do today. We're gonna do it next session. Abdul Tafa asks, on Starknet, Bravo seed phrase generate a different wallet on Argent. Oh, yes. You mean that you cannot import the same seed phrase that you export from Bravos into Argent? That's correct. And that is a bit silly. That's not compatible. But yeah, these two wallets, I guess they didn't agree on a standard for this. So yeah, no, you cannot import a wallet created in Bravos into Argent or vice versa. It should. I hope that one day it will. Thank you very much. Hope to see you all in a week. All right. Have a good one.